Starting, it says we're broadcasting. All right, so let me send a tweet out to the world.
Wow.
See if anybody, AWSTC3, can you see us? We have viewers. Okay, great. All right, thank you, plenary panel members and our viewers for tuning in to our first ever plenary panel discussion.
Wow.
If you've been watching, you know that we have with us from at least left to right on my screen, we have Andre Chiara, who just gave our opening presentation on threats to biodiversity. We've got Rowan Mott, who gave the presentation on spatial biases, and Stephanie Avery Gom, who gave the presentation on changes in population over time. And I'm really excited for this discussion because these three presentations work so well together. We've got biodiversity, population, spatial biases. So I wanted to kick this off by asking you guys, we saw from Rowan's presentation that there's really unequal sampling and studies across the world. And Andre and Steph, I wonder how you think that these bodies impact the results that you're finding.
Rowan, do you wanna go start or go first, or shall I?
You can kick off.
Okay, so I'm doing sort of two things. So I'm collating a bunch of data, all of the monitoring data that I can get my hands on in order to look at global trends in seabirds. And I want to do that for all seabirds together and for different groups of seabirds. But if I put all this data together into sort of one pot, I'm definitely going to be biasing the trend towards regions that have been really well studied. And in Rowan's presentation, we saw, the UK and a few other regions is just having a lot of work done, a lot of really good work. And so I think one way we can get around that, which again, both of our presentations sort of showed us, to look at the data spatially. So trying to get away from reporting results as sort of just like one number to kind of fit the whole globe, and really looking at results spatially. But there's just no getting around that. We're really, especially like Southeast Asia, like you kind of pointed out, it's sort of like a frontier still. Like there's a lot that we don't know. And we probably should be allocating more effort to working in those regions. And it's also cheaper to work in those regions. That's a point that you made, Rowan, in your talk, and I think it was a very good one.
Thank you.
So Andre, let me ask, sorry, go ahead, please.
Sorry. So one thing I think I replied to you, Max, is that when we're doing that work that I present here, this work was a desktop work, and trying to get hold of every single data set we can get. And one thing that gets clear, that there's a lot of places that there's the data deficiency, and when you work on in seabirds in particular, when you work on seabirds, it's not just about seabirds, of course, it's about what they're eating. And to do that, you have to have data of the elephant in the room, which is the industrial fishery. So and to get that quality data there, is very, very, very difficult. The data available is the FAO, which is very coarse. And when we're trying to get that paper published, we got a lot of criticism because the quality of the data we have for seabirds and for marine mammals was not in the same scale of the fisheries. So they say, oh, look, you cannot do anything about it. You cannot use it that. So, but we actually changed the journal. We pushed the barrier because, as I said, is the elephant in the room that no one, talks about and don't talk about because the quality of the data. That's the end of my statement.
I know that there have been a couple efforts lately. Pam Michael, who I think is doing her PhD down in Tasmania, has been looking at more sophisticated fisheries models to maybe bring at least those resolutions a little bit higher. So hopefully, if we can't get the actual data, some of these models will provide us a little bit more spatial resolution with those.
The Canadians, they did Daniel Pauly, which is, you know, a legend on fisheries. So they produce, I forgot now the name, but they are actually doing an amazing, you know, job with even get the FAO data and sort of refine them, which is fantastic. But for large scale, you know, study the whole globe, it's not available there yet. So they have lots for, you know, of course, Canada and, you know, North America, but not for other parts of the world.
Mm-hmm.
So, what I'm saying is that there's hope there.
And then let me ask you guys another question. So seabirds are famously, like a lot of marine species, but especially so, super mobile. When we're talking about let's say an albatross, its colony may be in Hawaii, but it's going to the Aleutian Islands to breed. So when we're looking at these global maps of population trends or biodiversity, how do we account for the fact that these ranges can span entire ocean basins?
Can I correct that?
Yes, please.
You talk about ocean seabirds, you know, because there's the whole bunch of, you know, coastal seabirds. They have a quite limited, you know, range. But you know, your question is pretty good. But I'm sure someone's give a better answer.
Rowan, what do you think about this?
I think in the actual paper that I'm writing based on the data that I presented, one of the key things that I'll be arguing for is to increase the amount of international collaboration that's undertaken, and particularly seabird researchers in established seabird biology nations like the UK and the US, and that reaching out to researchers in these kind of developing countries, and yeah, helping them to develop a seabird research and research published in peer-reviewed journals, so it becomes accessible to the global seabird community. Because yeah, I think our countries have the ability to do that, and it would be good to seed that thing in developing countries, because yeah, quite often the birds are roaming from breeding grounds on our coastlines into these developing areas, or the high seas where there isn't as much kind of policing of regulations perhaps. So yeah, these things, I think international collaboration is probably going to be a key step forwards to enhancing the prospects of conserving what we have.
Max, your question is quite interesting to me, because usually, and we're going to see that a lot today, you know, usually when you talk about seabirds, we talk about seabirds breeding on land and what can we do, etc., etc. But you know, in the case of penguins, 80% of the time they're at sea. So, and we talk, you know, disproportionately less about what's happening at sea, and if you know, they cannot go where they're feeding, you know, the feeding hotspots, or if we cannot protect the biolinks between, you know, the breeding side and where they feed. So all our efforts on land, you know, is not useless, but yeah, it's got serious damage.
Yeah, it'd be better if it could be coupled. I think one of the really big problems, and especially for regions with not a lot of data, is how do you, if you know where the birds are breeding, but you don't know where they are at sea because you haven't been able to get to the colony, you don't have money for tracking. I mean, we can't track all of the seabirds to find out where they all go. We sort of need another way to estimate where they're going to be within their global distribution. So in my study, I'm coming up with a way to approximate population distributions, which is very coarse and certainly not as good as the tracking data, but that tries to use information on foraging distances from the colony and the breeding season, and then the proportion of the year that they spend in the breeding foraging range, to at least zero in within the global range where a population might actually be. And so if we can kind of do that for, in these studies that have so much data, right, and you're talking about such large numbers of populations, if we can use this sort of shortcut approach to at least narrow down where within the global range the populations are, perhaps we can have a better sense of regions that maybe have quite a lot of decline or less decline. So that's a lot easier for, like Andre was saying, the more coastal seabird species. But when you're talking about lace and albatrosses, without tracking data, you really don't have a lot of options in guessing where seabirds from different colonies go.
Yeah, let me plug a couple sessions while we're on this topic. First of all, tomorrow at 11 UTC, we have a coastal species session, which is filled with great presentations from the Indian Ocean. There's going to be 3 or 4 there that I'm really excited about. And then also to 4:13 at 16:15 UTC, so 4:15 in the afternoon, we're going to have a presentation on how device accuracy affects the range estimates from these species distribution models. So as we move from GLS to PTT to GPS, and as device accuracy improves, I'm pretty excited to see what this presentation tells us about that. So Andre, I want to ask you a question about this seabird biodiversity hotspots map from your presentation. I think this was in the 5th slide. You have a raster spanning, excuse me, you have a raster spanning the entirety of the world's oceans. And I'm curious, what was your methodology in coming up with the biodiversity for these places that are far from colonies, well out at sea? Like, are you, was this a literature search, or were there other ways that you were coming up with these indices?
It's good question. But first I have to say I'm the brains of this work. It's Fran Ramirez. So I'm just doing the MC for this paper, the master of ceremonies. But what was very interesting, because this work started with, we are doing some work on little penguins. And then we start to get all these data from satellite data, things you get for free. And so, oh, this is exciting. And so let's take the plunge and let's do this for the whole world. So, and what we did is, for each pixel of the ocean, we look at what happens in the last 30 years. For each variable we pick, like ocean current, chlorophyll A, and sea surface temperature. So then for each of those variables, we calculate a slope. We have, for each pixel, we have 30 points for each variable. So then in some place we have a quite steep slope, some place we have, just a straight line. And then we accumulate, we sum that, we make an accumulation of that value for that area, and we put all the variables again standard in one single index. So we could calculate the impact of all those variables in every single piece of the ocean. That's how we did it.
So that gives you the environmental trends over time, and then
over 30 years.
Over 30 years, right? The past couple decades. How do you figure out the biodiversity indices for those points?
Okay, then the next step is to get hold of what's available there in terms of seabird distribution, marine mammal distribution, and fish distribution. So then we put that, as a layer on the map, and for each pixel, they said what's the presence of absence of particular species. So by doing that for over 2,000 species, we create these inks of biodiversity.
Excellent. Yeah, it's an impressive number of fish species that go into that.
Yes, thank you. Yeah.
So speaking of developing nations, which are often struggling to study the species in tropical areas, thinking in some of the northern areas of Australasia and the Indian Ocean, a lot of species there, much more so than polar species, are tied to subsurface predators. There's famously like boobies and frigate birds grabbing flying fish out of the water only because dolphins and tuna have forced them to the surface, when we have these really complicated ecological processes going on and these really important communities, how do we, is it even feasible to try to tackle these really complex systems from such a, pardon the pun, a bird's eye view?
Sorry, is your question, how do we manage at sea, seabirds at sea? Or how do we manage the distribution? I mean, how do we even model when we don't have a lot of at sea data?
Exactly. So I think that's part of what I'm asking is, like, when we know that foraging and therefore eventually populations are tied to these complex communities, can we even try to incorporate that into these models of what we think long-term trends are going to be when we lack such simple data as far as like distributions go? Or is this, is that too much pie in the sky?
I think eventually anything is possible, but when it comes to conservation objectives and trying to do what we can with what we have, then probably understanding those relationships is interesting from a scientific point of view, but not as interesting from a conservation point of view. I think understanding land-based threats like egging, poaching, introduced non-native species, those are, and also just even figuring out where are the seabirds, where are the seabird colonies, what are they threatened by, what are the trends doing? I think that's sort of the place to start in those regions where we don't have a lot of data. If the objective is conservation. If it's the pursuit of knowledge, then, I mean, that's sort of a different pot of money usually, and those studies can be really interesting.
As we try to predict forward in time, these relationships, they're so complicated and they can be so unpredictable. I'm thinking of the one Weimer-Skirch paper, Henri Weimer-Skirch's paper about how with climate change, as wind speeds are picking up, the population, the reproductive success of wandering albatross actually increased, which may be leveling off, may be anomalous. I think it would be entirely too optimistic to be like, oh, climate change is going to be great for the birds. We're obviously not seeing that. But as far as taking 30 years previous data and then try to go into the future, figure out what's going to happen next, I'm just curious how these ecological systems can potentially be incorporated into that.
Can I jump in here?
Please.
I can tell that you're a big fan of Henry.
Yeah.
So he's a legend. But to you say something there is, to me, is very interesting, that I think is going to be winners and losers in this rapid change in the climate, and even in the same species. And of course, in the Twitter, we don't have time enough to do that, to elaborate. But I'm trying to show that for little penguins, and something I know quite well now, it's that little penguins that breed in this particular part they call Bass Strait, which is between Australia and Tasmania. Tasmania is not a country; it's just part of Australia, but it's a long story there. So, but the birds breeding there, they're doing much better, which increasing in the ocean temperature, than birds that breed in the east and west coast of Australia. So for the same species in different places, the birds are responding in a different way. And the reason that they not respond in a negative way in the Bass Strait is because the anomaly we're talking about before, the 30-year anomaly, it's not in the Bass Strait. So there's no temperature anomaly in the Bass Strait. So if you can make a projection, if the temperature is keep increasing, you can predict that the anomaly is going to end up in Bass Strait, which is going to change the fortune of the penguins breeding here today. Mm-hmm. So to say that at one point in time will be birds that are actually benefiting from change in the environment, and the little penguins from the Bass Strait, they are doing extremely well, as now, but they may not be the case in the future. When it comes to the wind, it's very interesting, and because there is increasing wind, changes in wind direction, etc. And Stephanie, you're talking about before, how can we, make some predictions in places that we don't have the data? So there are some work now coming out that without having any tracking data, you just look at the prevail winds in around a particular colony, and you can draw a path of less effort. So they say, okay, this bird here, I think is going to follow this path because it's less effort to travel in this way. And when you do this, and we sort of, oh, sorry about my dog. So when you do that and overlay with actually tracking data, it's just incredible. Works really well. So I think now with the quality we have of, in satellite data for winds and for a lot of other things that the Europeans now coming up with from Copernicus, they put some new satellites up there. We are going to get seabird biologists. We're going to get so much, really good quality satellite data that we can actually help us the predictions of seabird distribution, even though if we don't know the distribution by, in real time.
Yeah, it was disappointing to see that the Rapid Scat satellite came down last November. I was really hoping that one would stay up longer. But there is so much good wind data coming in, and I do think that's a really underutilized variable for looking at these seabird distributions.
Yeah,
we have a... Sorry, go ahead, Steph.
I just said that's a very good point.
We have a question from Twitter. Saskia asks, in context, how important is planning and funding targeted local validation for large-scale distribution models? Rowan, we haven't heard from you in a while. What do you think?
I think it's possible if the large-scale distribution isn't too large. I think it all depends if large-scale is relevant to local area that is the target, then that's fine. But I think as it becomes kind of global scale, then potentially it starts to lose its relevance a little bit.
Yeah, I would agree with that. I definitely think the global stuff is only, sorry, am I on mute? No, I'm good. The global research is only possible because, in a lot of cases, because of the small scale, the local scale work. And by like so many thousands of researchers at a humongous cost already. I think the question of scale, like a lot of these global studies, if you were to, so I come up with an average population trend for a group of seabirds in a half-degree cell on a global map. Is that really going to tell us exactly what's happening to those seabirds in that spot? Not really, because it's integrating across a bunch of populations. And I think that it's sort of helpful to think about sort of two different scales, sort of the 30,000-foot view down on the planet to see kind of what's happening and where the work is happening. And then sort of the sea level work, which is often where, that's where the conservation actions are really happening. The demographic data is being collected and the population trends are being monitored. So I think these sorts of global studies are really useful for helping organizations like BirdLife, East Asian Australasian Flyaway Partnership, or the Arctic Migratory Bird Initiative of CAF to plan internationally and to sort of look at where they can maybe focus more effort. But I'm not sure that I would sort of advocate for taking a global map and then expecting to find exactly on the ground. Like, I'm not sure you could validate and find the exact same answer. And I'm not sure if I'm getting Saskia's question. Like, I'm not sure if I'm understanding it exactly correctly. Maybe she's on Twitter and she can say if she has any follow-up questions.
Hopefully she'll follow up. So I know it's very late where she is, so she might be going to bed soon. But I think part of what she was getting at is more along the lines of Andre's biodiversity map. Like, pick a pixel, go out and maybe do a shifting survey there for a period of time and see if are we actually seeing the number of species we expect to see. That's obviously super simplistic, but along those lines.
Yeah, no, and I think it would be nice to know that areas like hot spots compared to cold spots are actually different. Because a lot of these global ranges are massive ranges, and they capture really large areas, and they're not density maps of where birds really are, or occurrence maps or anything like that.
Can I jump here and sort of sidetrack a bit, Max? But it's relevant. So, for people like Rowan and Stephanie, and interested in in data sets, lots of data sets from whatever they can put hands on, and I think the biologists in general, they're still very protective of the data. So they hold that, really, really close until they publish, and sometimes they publish and they don't want to share that. So then we look at oceanographers or meteorologists. They put the raw data there on a daily basis. So we have sea surface temperature every day. We have you have your weather map that they all put there for free, and before they do analysis. So I think we need to catch up with that and make sure that, okay, we get funding. This is not my data. This is a public data we have to put available. One thing when we're doing this work that I presented is the lack of data. It's the lack of seabird data, and we know that for most of those distribution which we got from the IUCN, which is kind of coarse, we know that for that there's lots and lots of tracking data that people don't make available.
And I think that may reflect some of the cultures that sprang up around this. I know that so much of sea surface temperature data has its origins in the merchant marines and commercial ships. This was seen as like a service we were providing, whereas tracking data in the beginning, it was so expensive that it's hard to let that baby go. But I think you're right. It's like we're reaching a time where that needs to be public data in order to get the most effective conservation goals. And I think we are seeing a lot of movement in that direction with movebank.org. I know it's been a really effective database for not just seabirds, but a lot of different species. And I'd love to see more data in there, especially for students like myself who don't necessarily have funding to get out into the field that much. It'd be great to piggyback off of others.
Yeah. And also time to make a plug for the BirdLife also has an effort to collate seabird tracking data. And there has been an effort to build a global colony registry through the World Seabird Union. And if there's anyone out there that has a lot of money and wants to fund a very, very important project,
sure.
This is not my project, but there's a lot of data out there, and I think people are coming around and they're becoming more willing to share, and as people do share, it will become more common, more popular. And we have the infrastructure. What we don't have is an endowment or some sort of long-term funding plan to maintain the database in the long term. So we don't need, we need people to share their data, but we don't even need to create a database. We already have one. We just can't support it. And by we, I mean the seabird community, like not me specifically. Mm-hmm. But you know, I think it is going that way, and there's definitely been some movement and some interest, but what's needed is a way to fund it in the long term.
Okay, and it's that brings us to the close of this session. I feel like that's a good note to end on, a call to arms. Let's all share our tracking data. I'm sure that'll start a bit of a discussion.
And our population data.
And our population, all of our data. Let's just put it out there the second we can.
And give us more money.
Yes, everybody. Let's all get money.
Which really, if you publish a paper, a lot of journals do require you to make your data public, and it could be made public in a format that other researchers could use.
That's true. That's true. And then that's protecting both the researcher and the public. Okay. Thank you very much. Our plenary panel, we have Andre, Rowan, and Steph. I really appreciate you guys sticking around. I'm going to take this off the air, but if I could get you to stick around for just a minute, I want to say thank you a little more thoroughly. To our 16 viewers, more than a dozen. I'm excited. Thank you very much for tuning in. I hope you're enjoying WSTC3. And yeah, stay tuned for the next couple of days. We have a lot of really amazing presentations coming up. So thank you very much.
Thanks, Max.